This is part 2 to talking about arc length and sector area. Earlier we talked about if the circle was cut into equal parts or divided into equal parts, and in this case it's not divided into equal parts. You're usually given an angle measure, and this is a central angle because the center is at the or the vertex is at the center. So with the central angle, if I know the measure of that, then I can find the arc length and the sector area. And there's a formula for this, and it is found on your geometry formula sheet that you have, and it's found in the first column, down here about 2/3 of the way down, arc length of a circle, and then at the bottom, area of a sector of a circle. So let's write those formulas in here. So arc length is 2 pi r theta, and theta is the angle measure I'm given, divided by 360, because 360 is my whole and 75 degrees is going to be the part of the whole I'm talking about. And then the sector area is pi r squared theta divided by 360. So basically it's the circumference formula times the part of the whole circle, and the area formula times the part of the whole circle. So let's use these formulas. So in number 5, we have, we want to find the arc length and we want to find the sector area. So arc length, I just use my formula for arc length, r theta divided by 360. And so I plug in my numbers, 2 pi and r is 7, theta is 75 degrees, and then 360 degrees. And when I plug that into my calculator, I find that this arc length is 9.16 yards. Now, I use the formula for the area of the sector to find the sector area, and it's pi r squared theta divided by 360. And so I have pi, 7 squared, and then times 75 divided by 360. And then when I plug that into my calculator, my final answer for that, the area of this sector of the circle is 32.05 yards squared. Okay, so the big thing that you need to remember is you need the formulas that's found on your formula sheet. You need to know the radius, and you need to know the central angle, or the angle that we're talking about, the part of the circle that I'm talking about. The only way that this could change is, what if I wanted to know the other part that's not this part? I would have to find this angle, which would just be 360 minus 75 degrees, and then plug in that angle to find this portion of the arc, or the major arc there. Okay, so in this situation down here, I'm still using the same formula. I have 2 pi, and then I plug in my radius, and then my degree is 225 divided by 360. And when I plug that into my calculator, it's 58.88 feet. And the unit is just feet, because I'm just measuring the distance around this part of the circle. And pi r squared, so this is the area of the sector, this area. Pi r squared, so pi times 15 squared times 225 divided by 360, and that area is 441.56 feet squared. Now, I was talking a second ago about, well, what if I wanted the other part? So this is the shaded part. What if I wanted the non-shaded part of the circle? I would just need to take and find this angle, which would be 360 minus 225, and instead of, everything would be exactly the same except for in the case of 225, I would substitute in 360 minus 225, and so that's 135. So this would be, that part of the circumference would be 135 out of 360, and the part of the area would be 135 degrees out of 360. So hopefully that gets you up to speed.